For years, the Saab Gripen was considered a clever, efficient fighter jet built for nations that wanted high performance without paying F-35 level money. But a quiet engineering shift began behind the scenes. One so unexpected that when the results appeared in NATO's system reports, analysts were confused, then shocked, then deeply concerned. This shift came from Rolls-Royce, a company most people associate with luxury cars, but whose aerospace division holds some of the most advanced propulsion knowledge in the world. The modification program started secretly when Sweden's engineers realized the Gripen E could only reach its true potential if its engine subsystems were radically optimized. Although the F414 engine powering the jet is made by GE, the internal airflow channels, thermal distribution layers, control algorithms, and micro-tolerance components were redesigned with Rolls-Royce's help. NATO did not know this collaboration was happening, and Sweden had no intention of announcing it publicly because the upgrades would fundamentally alter the jet's combat signature. The first major change was in heat dispersion. Modern fighters are tracked not only by radar, but by infrared sensors mounted on drones, satellites, and long-range missiles. By redesigning the engine's thermal routing, Rolls-Royce helped reduce the Gripen's heat signature far beyond what any single-engine aircraft had ever achieved. NATO's test sensors recorded abnormally low IR readings and initially suspected a system malfunction. They recalibrated the scanners, and the readings still came back extremely low. A single-engine jet was behaving almost like a stealth twin-engine design, and that alone raised red flags across NATO intelligence. The second upgrade came from optimizing the fuel burn curve through redesigned airflow pathways. The Gripen E's range increased significantly, giving it endurance numbers that traditionally required 2 engines. This was especially attractive to countries like Canada that need long-range patrol capability in the Arctic NATO. Analysts were stunned that a jet weighing far less than an F-35 could travel nearly the same operational distance with more flexibility and lower operating cost. The third breakthrough was digital, the engine control system. Rolls-Royce introduced a new adaptive response model that allowed the engine to adjust thrust output faster than before, giving the Gripen E an almost instantaneous acceleration profile. Pilots reported that the aircraft jumped forward in ways it never had before. In dogfight simulations, this created major problems for NATO's older interceptors, which struggled to track the jet during sudden maneuvers. Sweden quietly stored these results, but NATO eventually accessed snippets of performance data, enough to realize the Gripen E had evolved far beyond its original classification. What truly shocked NATO, however, was not any single upgrade, but the combination of all of them. Reduced heat signature, extended range, faster throttle response, and dramatically improved survivability. And all of this was achieved without changing the engine's exterior, meaning the jet still looked identical on paper. When NATO's technical committee reviewed Sweden's new performance logs, they realized something unprecedented had happened. A single-engine fighter had jumped into the same performance tier as multi-billion-dollar stealth jets without requiring the expensive maintenance or sensor vulnerabilities that plague them. Many NATO members quietly asked Sweden for clarification, but the official responses were ambiguous. The truth, that Rolls-Royce had silently re-engineered the most sensitive parts of the jet, only leaked later through internal documents. By then, the Gripen E had already become a new kind of threat and opportunity, a low-cost fighter that suddenly rivaled the world's most expensive aircraft. NATO officials initially believed the improved Gripen performance logs were manipulated because the numbers simply didn't match what a single-engine fighter should be capable of. But when satellite tracking, IR scanners, and AWACS radar data all confirmed the same results, they realized something serious was happening behind the scenes. What they didn't yet know was that Rolls-Royce had quietly introduced a new airflow pressure modulation system inside the engine that allowed the Gripen to operate with exceptionally stable thrust at high altitudes. This meant the aircraft could climb faster, stay higher, and burn less fuel while doing so. A combination that normally requires heavy stealth platforms or advanced twin-engine designs. The system worked by redistributing micro-variations in air pressure using a set of internal vanes that reacted in milliseconds. These vanes weren't visible from outside the engine and didn't require Sweden to change any official specifications, yet they changed everything. Pilots reported that the Gripen now felt more balanced at extreme altitudes, giving it the ability to intercept targets that even some larger NATO fighters struggled to reach quickly. This alone triggered internal discussions inside NATO about whether their own intercept doctrine needed to be updated. Another hidden improvement was the reduction of engine noise across certain frequencies. This wasn't about making the aircraft quiet to the human ear. It was about disrupting acoustic tracking drones used in modern battlefields. Rolls-Royce modified internal components so that the engine emitted fewer stable frequency bands. This meant that autonomous drones trying to triangulate the aircraft's position through sound suddenly had far less reliable data. NATO's Drone Warfare Division tested this using simulated Gripen signatures and realized that the jet could penetrate some drone defense grids without being flagged as a priority target. While these upgrades shocked NATO, what came next genuinely worried them. Rolls-Royce engineers had helped build an adaptive thermal intelligence loop inside the Gripen's digital engine controller. This system monitored heat buildup in real time and autonomously shifted cooling paths microseconds before hotspots formed. In combat scenarios, this made the aircraft far more resistant to IR-guided missile locks. Older NATO jets needed manual throttle adjustments to reduce their heat signature, but the Gripen now performed those optimizations automatically. It could appear, disappear, then reappear on IR scopes with unpredictable timing, making it extremely difficult to engage. Sweden had kept these capabilities secret even from most of its own political leadership, sharing details only with a small technical circle. This secrecy led to tensions when some NATO members began asking pointed questions. Why was the Gripen E suddenly outperforming expectations? Why did some of its sensor logs resemble stealth aircraft, even though it had no formal stealth coating? Why did Canadian evaluators report acceleration profiles that didn't match GE's official data sheets? Eventually, internal NATO analysts discovered traces of Rolls-Royce's involvement by cross-referencing engine vibration signatures with known Rolls-Royce engineering patterns. Even though the company hadn't manufactured the main engine, the microscopic vibration patterns matched internal components typically built under Rolls-Royce's precision microengineering programs. This raised the biggest concern yet. If Sweden and Rolls-Royce could collaborate quietly on this level, other countries might begin doing the same, bypassing NATO's usual oversight on fighter jet development. Behind closed doors, US officials warned that the Gripen E was becoming a strategic wild card. It was cheap enough for smaller nations to buy, but now powerful enough to threaten heavily defended airspaces. And because the upgrades were internal and invisible, traditional export control politics simply couldn't track them. For the first time, NATO realized that the age of expensive stealth fighters dominating global air power might be ending, and that the tipping point had been triggered not by a major arms race, but by Rolls-Royce quietly re-engineering the heart of a single-engine jet, as NATO struggled to understand how the Gripen's capabilities had shifted so dramatically. Sweden and Rolls-Royce were already working on the next layer of internal enhancements. These upgrades were focused not on raw engine power, but on survivability, deception, and autonomous threat management, areas where even advanced NATO jets often relied heavily on external pods and bulky equipment. The Gripen E, thanks to its modular architecture, could integrate these systems directly into its engine control environment, making the entire aircraft behave like a single intelligent organism rather than a collection of separate subsystems. One of the most surprising developments came from a digital harmonization process Rolls-Royce introduced. Modern fighters generate vibration signatures that enemy sensors can use to identify aircraft type at long distances. Rolls-Royce created an algorithm that subtly shifts micro-vibrations inside the engine, depending on altitude, speed, and threat environment. As a result, the Gripen E could mimic vibration signatures of different aircraft classes. In simulated combat, some NATO radars initially categorized the Gripen as a drone, then as a trainer jet, and only later recognized it as a fighter. This inconsistency created chaos in threat classification systems that rely on stable vibration databases. Another breakthrough involved the integration of microburst cooling pulses. Instead of releasing heat in a predictable curve, the Gripen's redesigned engine periodically emitted tiny, irregular bursts of cooler exhaust, confusing IR tracking systems. Missiles that normally locked onto a steady heat plume suddenly found themselves unable to maintain a stable trajectory. In NATO's internal war game simulations, this effect increased the Gripen's survivability by up to 40%. What alarmed analysts even more was that this advantage required no exotic materials and no stealth coatings, only smart engineering inside the engine. As intelligence reports accumulated, a few NATO engineers began raising the question no one wanted to hear. If Rolls-Royce could do all this for a relatively small and affordable fighter like the Gripen, what would happen if other nations requested similar covert optimization programs? Countries with limited budgets could suddenly field aircraft with performance characteristics similar to top-tier NATO fighters. This possibility threatened not only the technological balance, but also the geopolitical leverage that came from expensive Western aircraft sales. Meanwhile, Sweden noticed a surprising shift in international interest. Countries that had previously dismissed the Gripen as too light or too simple now quietly asked about its upgraded variants. Several air forces requested demonstration flights, but were denied access to the most advanced internal configuration. Sweden recognized that the new Gripen was no longer just a fighter jet. It had become a strategic asset that could alter regional power balances. Even within NATO, some members began privately questioning whether Sweden's increasing technological independence might one day challenge alliance cohesion. The shock reached its peak when a secure NATO briefing revealed that the Gripen's new acceleration curve outperformed predictions from classified US simulators. This meant that American analysts, who had modeled the jet extensively, had failed to anticipate how the internal upgrades would affect real-world performance. The report warned that NATO must assume the Gripen was now capable of maneuvers previously thought impossible for a single-engine platform. Some officials even recommended building new training programs specifically to counter the Gripen in dogfight scenarios. Through all of this, Rolls-Royce maintained complete silence. They issued no press releases, no technical papers, and no public statements acknowledging their involvement. Yet inside NATO, everyone understood that Rolls-Royce had essentially rewritten how a fighter jet could evolve. Not through massive redesigns or billion-dollar programs, but through smart hidden upgrades inside the engine's core. What made the situation even more ironic was that Sweden had never intended to threaten NATO. Their goal was simple: create a fighter that offered maximum performance, reliability, and independence without depending entirely on US technology. But in doing so, they accidentally created a jet that exposed vulnerabilities in NATO's own aircraft doctrine. For the first time, Western defense strategists had to consider a future where agility, adaptability, and silent engineering upgrades might matter more than raw size or cost. By the time NATO fully grasped the scale of the transformation, the Gripen E had already carved out a new identity: a lightweight fighter with heavyweight consequences, shaped quietly by Rolls-Royce in a way that rewired not just its engine, but the expectations of modern air combat itself.